All right, the very last chapter we need to do for this class is chapter 12. Still a little bit about geometry, but now we're going to start switching to looking at like area and things like that, okay? So 12.1, we're looking at area of a rectangle and a parallelogram, okay? So when we have a figure like in your book for chapter 12.1, where it looks like this and each side is 1 centimeter long, then we say that the area of this is 1 square centimeter. Okay, this is what we call a unit square. So when we talk about area, we're talking about how many of these unit squares, and it depends on if you're measuring in like centimeters or inches or feet, but how many of those unit squares can fit inside the figure that you're given, okay? Area is different than perimeter. So the perimeter just talks about the distance around. Okay, so if you were to start in one corner, what would it take to walk all the way around the figure? And the area, like I said, is how much fits inside, how much room there is. Okay, so two very different measurements. Perimeter is around the figure, area is what fits inside your figure. Okay. Perimeter is always in singular units, so like inches, centimeters, things like that. Area is always square units, so we can say square inches, square centimeters. Another way of writing that would just be using a square, but it's just on the units itself. Okay, so if you're given a rectangle like this, and it's 1 centimeter on one side, and 2 centimeters on the other. We're asking how many of these unit centimeters can fit inside. Well, here would be 1, and here would be 2. So the area of this would be 2 square centimeters. Okay, and if I get a little bit bigger, and I say this is a 3 centimeter measurement here, and a 2 centimeter measurement here, how many of these are going to fit in? So I'm dividing them into 1 square centimeter. So if I go like this, put a line, I get 1 here and 1 here. And then here's 1, 2, 3. So I can fit 1, 2, 3, 4, 5, 6. I could fit 6 of these square centimeters. So my area on this figure would be 6 square centimeters. Okay, so if we start looking at the relationship here, the area of a rectangle then relates the length and its width. Okay, so for a rectangle, we can say that the area is the product of the length times the width. The length is generally the longer side, and the width is generally your shorter side. Right, so here, length and width, 2 times 1, we get 2. Here, the length is 3, the width is 2, 3 times 2 is 6, giving us the area. Okay, so we can also look at a parallelogram, and parallelogram kind of just looks like a rectangle on a slant. Okay, it just says that opposite sides are parallel. So we can look at a parallelogram much in the same way. Okay, so we would say that it has 4 sides and opposite sides are parallel. Okay, so looks kind of like this, right? So these two sides are parallel and these two sides are parallel. Okay? In a parallelogram, you have a base being one of your sides, and then you have a height where the height is perpendicular to the base. Okay, so if I'm going to use this side as my base, then my height has to be right here. So we're going to make it perpendicular. Okay, so if I take that little shape, which happens to be a triangle, and I cut it off and turn it around, I can put it right here, and I end up getting something that looks like a rectangle. So this tells us that the area of a parallelogram is going to be very similar to the area of a triangle. It's going to be the length of the base times the height. So the base is a side, and the height is perpendicular to the base. Okay? So then, looking at some examples dealing with area, okay? We want a parallelogram where the area is 112 square centimeters and the height is 8 centimeters. We can use that to find the base, okay? Because the area of a parallelogram is the base times the height. So the area is 112, the base we don't know, and the height is 8. So to get b by itself, we divide by 8, and we get that the base of this parallelogram is going to be 14 centimeters. Because these are units and area has units on it, we want to make sure that we write units for everything, okay? So just using what you have to find something that's missing. All right. Then, say I have a figure that looks like this, and we want to find its area. Okay, dimensions here are 3 centimeters, or not centimeters, sorry. We're going to use meters this time. So 3 meters, 2 meters, this is 2 meters, and this is 1 meter. Okay, we want to find the area of this entire figure. So you can kind of divide it up into rectangles. So if I put a line here, I can find the area of this rectangle. So that red area is length times width. So 2 meters times 1 meter. So that's going to give us an area of 2 square meters for that little red rectangle. Okay. Then if I draw in a line here and a line here. Okay. Actually, we don't need to do that. We're just going to have this rectangle. Okay. This blue one is another rectangle. So that area is going to be the length times the width. So 3 meters times 2 meters. So that's 6 square meters. So if the blue is 6 square meters and the red is 2 square meters, then our total, we're going to add them up and say that the total here is the red plus the blue. So that's going to be 2 square meters plus 6 square meters for a total area of 8 square meters. And that allows us to find the area of any figure that's a parallelogram or a rectangle or a combination of the two.